A special case of kinematics in one dimension is motion with constant acceleration, or the constant acceleration equations. Basically, constant acceleration is a situation that shows up very often, and so what we're doing here is using our knowledge of kinematics to derive these equations ahead of time. And once we found the equations, we won't have to start from scratch every time to do the calculations, but rather we can just plug the numbers into the equations that we already have. So we start with our model of constant acceleration. What we're assuming is that we have some object represented as a particle. That object is undergoing some period of constant acceleration. So the particle is going to have an initial velocity, it accelerates for a time, and it's going to have a final velocity that's different than the initial velocity due to the change due to that acceleration. This acceleration has to go on for some time interval to elapse while the object is accelerating, and if the object is accelerating, if it's moving while it's accelerating the whole time, it must undergo some displacement as well. So we end up with 5 constant acceleration variables: the initial velocity, the final velocity, the acceleration, which is constant during that interval, the displacement of the particle while it's accelerating, and the time that passes while the object is feeling that constant acceleration. We can use kinematics to find 5 constant acceleration equations. These are important. You're going to need to know them. These are the 5 constant acceleration equations here. And again, these are derived from kinematics in 1D. The underlying assumption, and the thing I'm going to keep mentioning to you, is that the acceleration is constant. These only work for that special case when acceleration is constant. But that's a special case that shows up a lot, and so it makes these very useful. We had the 5 constant acceleration variables, and using those five variables, we're able to come up with 5 equations. Each equation is missing one of the 5 variables, and so each equation only has 4 variables in it. So if you have 3 numbers, you're able to calculate any of the other values. Notice that the constant acceleration equations are all mathematically equivalent. We're going to see that we can derive 4 of them, and then we can use the 5th one. We can do some algebra to show that they are equivalent to one another. But it's helpful to know all 5 so that you can save yourself extra steps of having to go through multiple sets of calculations. These constant acceleration equations, as they're given here, are best known for a well-described interval. And by well-described, we mean that you know the specific time or the specific displacement that we're trying to measure, or you know the specific starting or ending velocity that you're shooting for. If you know a lot of information about the starting or ending points of this interval, these equations are going to help you find the other variables that have to be there during that interval to make that motion happen.